Hello, good morning. Per your request, in this video, I will show you how to use the GPU simulator so that you can do the homework. Okay. At first, I will show the information of on the simulator itself. This is my homepage. And if you go down to the project, okay, and the topic processor, okay, I have many small projects concerning computer architecture, and the GPU that we learn is here. So we click in to see the information on this GPU. Okay, I call it a natural graphic processing unit. And you can see the topic on how to use assembler and simulator. Okay, right? It did not show you much of the details, but you can get started how the command line, what kind of command line to be used. And below that, you can see the package, right? All right, so you can get the simulator itself from this package. This is, and I already got it, so it is under this directory npu4 once you unzip the whole package. Okay, and within that the tools we have assembler, all right, document, the GPU simulator, and the test directory, which contain a few number of already built objects. Okay, so at first I show you the program and explain a little bit of it. So we use that as an example how we can run it. All right, so let's do that and open the file. Oh, actually I already have one copy. Okay. Okay, let's concentrate on this very small program first. It is, as a comment on the top, it is summing the number from 1 to 10. So the result should be 55. And you don't have to actually understand all the instruction, because the session is just to get you to be familiar with the kind of special instruction used in GPU, which we call the vector instruction, where one instruction can perform many operation at once, because GPU have many execution units, right? So if you cannot write the program, it's okay. Just explain this program so that you can understand what I show. All right. At first, it's just we have a few register. Remember that each execution unit have its own complete register set. Okay, so we said clear the call 1, right? Clear register number 1, clear register number 2, and number 3. Okay, so it sets some kind of index and summation, right? And then the fourth instruction is just put in constant number, so we can compare if we already sum the number up to that number. It's number 10. So we add immediate 10 to register number 3. Okay, and within the loop, it's a check, right? If the index it is register 1, we use register 1, right, equal to number 10, which we just put in. And if it equal, then the loop should terminate. Otherwise, it's right. It should terminate. So it go to terminate, the exit, and sys4, it means stop the simulation. Otherwise, it just sum the number. The number is is I, right, in register 1, and the result store in register 2. So it add 2 to 1 and store a result in register 2. And then increment register 1. So the first is 1, then 2, then 3, right? And then repeat going to the loop. Okay, nothing much, right? Okay, so we have I have the command line or my terminal, okay, or you can console, depend on which platform you use, either Windows or Mac OS. Then already added right directory. So I have that program here. So I type it up for you to see. Add 10 text, right? And you see the program I just explained. Right. In our tool, we have assembler. So we have to convert this program into object or machine code. Okay. So I should say ASM4 input is add 1, add 10.text, right? And let's see, I think output may be on the screen or maybe to the file. Let's have a look. Okay, so it's output to the screen. So I have to do that and keep at 10.obj, okay, right? And we now have the machine code .obj here. Let's have a look. Okay, so it's a kind of encoding of the machine instruction, right? Not many instructions. All right, so this is the one that the simulator will be used. So let's continue and use the simulator, which in well, visit the directory for you to see. The simulator is sim4. Okay, so we can call sim4, and the file to be run is add 10.obj. Okay, so it now it get into the simulator itself, and there is some command line loop in the simulator, right? You can find the command used inside the simulator by typing H, it means help. So quite similar to other simulator that we used before. Then we can go G and then it go all at once until the simulator complete, or single step, which I will show, and the rest is not so much of the anything you need to know. Okay, and we may want to show the register, so R. So let's try R, and we can see the state of register. There's so many registers, right? 32 of them, and the on the same line is show each execution unit in the simulator. Within simulator this, simulator default having 4 execution units. So you have a register 0 of each execution unit and so on. Okay, everything clear in the beginning. Okay, so we run the first instruction, which is clear, register number 1. Okay, so it become exclusive or of the register. So exclusive or with itself, it means clear. Okay, it results in 0. And with single step again, right? I think the second one is clear register 2, right? Which you cannot see anything because it's already 0, and clear register 3. Okay. When we start the program, you should not assume that register have any value. You have to set it. Okay. And of course, this is simulator, so I can set the right value to it. But if it's a real hardware, when it turn on, it does not mean register is 0. It means something. Okay. So as a good habit, you have to initialize all the variable you are using in your program. The next is to put the number, immediate number, into register. So, right. So it's add immediate. Okay. 10. It means the number 10 will be put in register 3, and you can see that this is a vector instruction because it's is all the execution unit of 4 core already run this instruction, right? Just the same instruction all at once. So you have number 10 on register 3 for all the execution unit. And then the next is, I should keep the program beside, right? So otherwise it's difficult to see. Okay, the next will be comparing. Okay, and when we compare two registers, and when we keep the result in register 4, so did it check that the number already reached the 10? So of course the first time in the loop it isn't. No, so go boom boom, and register 4 is mean less than or equal. It's true because the I initially is 0 and then increment until it's 10. So the first is all the less than or equal is true. So it continue. The next is jump if it is false. So it does not jump. Okay, does not jump then mean the next sentence should be started at the program line 6. Okay, you can see 6 here. So now it add the value. Okay. Okay. And you can, and in next instruction is increment the number that number I, so I 1 2 3 4 5 6 7 8 9 10. Okay, so now it add then become 1. Okay, and we go to the loop twice so you can see the result. Okay, and then it's it's already in increment I. Okay, and the result of the summation is in result 2, still 0. And we go to the loop. So we go, when we jump, we go back to line 4, I think. Okay, so make it 4. So it repeat the loop now. Okay, and it's still less than or equal. So it go to the loop again. Now it add the 1 to the sum. So the sum, which is reason number 2, become 1. Okay, and you can see interesting here is every execute unit run at the same time. So we have duplicate of the result because this example program does not make use of having 4 core. It just perform in running the program exactly just like it have only one core. So right. This is just to show how it works. Okay, which is not the right, not taking advantage of the parallel processing. Okay, so we go to the loop again, right? And we now the I become 2, and if we add I to the sum, then it should be next step should be register 2 to be 3. Jump add now, right? So you can see that it go on like this until the test is 1 reach 10 and then it go out. So to continue, we don't want to run each step again. So we run through all of them. So we use the command go G, boom, and it run until the end and it finish. If you want to see result, you have to see the register. And yes, the register 2 contain 55, which is the result. And the index go to 11. Okay, more than 10. Okay, and it stop there. Okay, so we add 0 to 10 rather than 1 to 10. All right. So to stop the simulator, you use Q, quit, boom. So it tells us it execute 62 instructions and using 411 cycle. Hope you now can run the simulator by yourself quite easily and enjoy your holiday. Bye bye. See you next time.